$345,000. $9 a unit times 23,000 units is where we get the 207. Contribution margin you can calculate by taking $6 per unit times 23,000 units, or you can simply say 345 minus 207 is 138. In that particular scenario, there was no increase in fixed expenses, so those are still 70, bless you. And so your new net operating income should have been 68,000. Okay? Questions on that first one? Please ask if you aren't sure where we got a number. The second one, the second scenario, you had a 25% increase in the unit sales. So just like we did in the first scenario, we took the units that were currently being sold, multiply by 1.25 to add that increase of 25% to get the new number of units sold at 25,000. Now we did have a change in one of our per unit values. The problem said that selling price was going to drop by $1.50, right? So that meant we went from $15 per unit to $13.50. No mention of the $9 changing. So companies do it all the time. They lower their selling price, right? To do what? Attract more sales. But it still costs them $9 a unit to make whatever it is this is. $13.50 though minus 9 is now a new contribution margin per unit of $4.50. So these per unit values now, you want to multiply by your new number of sales, or 25,000. So it's $13.50 times 25,000 gives you the 337,500. $9 times 25,000 is the 225. Again, you can just do the subtraction here, or 450 at 25,000 units should be 112,500. No increase in fixed expenses in this scenario. So now our net operating income is 42,500. When you think of it as like, what happens if I do this? What happens if I do that? And how does that affect my bottom line? Any questions with number 2? If you made a mistake, see where you made a mistake? All right, number 3. And number 3, we had a decrease in unit sales because we had an increase in price. And that happens a lot of times, right? That's economics. You guys learn that in Econ 101. There aren't as many people willing to pay the higher price for the item, so your sales drop off a little bit. In this case, you had a 5% decrease in sales. So we talked about where that 95% came from, right? We said if we're increasing unit sales, then we add that additional percentage to 100% and multiply that new number times the units. If we have a decrease in unit sales, we say 100% minus the 5% decrease in sales is where we get the 95%. Because we only sold, in this case, we're only selling 95% of what we previously sold, or 100% minus 5%. So that new number of units is 19,000. So our selling price increased by $1.50. That's why it's now $16.50. But again, variable cost didn't change. It's still $9 per unit. Because the selling price per unit changed, though, my contribution margin per unit also changes. And also in this particular example, we had increase in fixed expenses of 20,000. So they went from 70 to 90,000, right? So we had kind of a lot going on in that one. So 1650 times 19,000 units, 313,500. $9 times 19,000 units, 171. 750 times 19,000 is 142.5, or you can just take 313.5 minus the 171. Okay? 90,000 because we had to add the extra 20,000 of fixed costs, gives us net operating income of 52.5. Questions? Okay. Good with all the numbers? Sure? Okay, finally, scenario number 4. So in this case, sales dropped by 10%. Number of units dropped by 10%. So 100% minus 10% is 90%. So we're only selling 90% of the units previously sold, or 18,000 units. It said in the problem that your selling price was going to increase by 12%. So if your selling price was $15, we do that the same way. We say 15 times 1.12, and that gives you the $16.80, right? Or if you want to do the two-step process, you can say $15 times 12% is $1.80, and then you got to take and add the $1.80 back onto the 15, right? Either one, that's still get the same answer. This problem, or this scenario, also said variable expense is going to go up by 60 cents. So now we had, this is the only one where we had a change in variable cost. So variable cost was $9 before, it's now $9.60. Now your new contribution margin per unit then, do the math, is 720. So now we're taking these per unit values times 18,000 units instead, right? And so 1680 times 18, 960 times 18, 720 times 18. Fixed expenses didn't change in this problem. So now our net operating income is 59.6. Okay, questions? All right, so homework works like that. You guys get an opportunity to check your work. Hopefully you took down notes or made corrections. You can't turn homework in after we go over it. Homework is basically a grade booster. Is really all it is. So you choose to do it, it's going to help your grade. And if you choose not to do it, it won't help your grade. Any questions on any of those 4 scenarios there? All right, those are yours to keep, obviously, because they'll come in handy when we do review questions for the test and also your preparation for the test. Okay, so today we have one more item to cover in Chapter 5. And that's what we're going to do right now. And then I have review sheets. With this chapter, I don't like to wait until we cover Chapters 6 and 7 to go back to Chapter 5, simply because there's a lot going on in Chapter 5. And the review I have for you is pretty comprehensive, and it covers just about everything that we've done in Chapter 5, so I like to give it to you early so that you can start working on it and not kind of forget everything we've done so far. So once we get done with this last ratio, then I'll give you guys those handouts. Okay? All right, so degree of operating leverage is the last item or topic that we're going to cover in this chapter. And again, if you fill out the table, that table we've been talking about now forever, and you have the coffee clutch table, we're going to come back to that for this one as well, but if you fill out your table, your contribution format table, the numbers that you need for this formula are right on that table. This formula is actually pretty simple. We're going to focus on, again, the interpretation. So we're going to compute something called degree of operating leverage. There are many variations of this DOL, as we like to call it for short, degree of operating leverage. This is also a calculation or a term that comes up quite a bit in finance. So even if you're not an accounting major, you're a business major, you're going to take Finance 202. You're going to talk a lot about degree of operating leverage. You take in a master's program, you'll hear this term lots of times. So this is not just an accounting thing by any means. But it's going to be used to explain how changes in sales can be used to predict changes in net income. So if you think about our financial statement, sales minus variable costs is contribution margin. Have I said this enough? You guys remember this, right? Oh yeah. So this is going to help us say, okay, when something happens here, let's figure out right away what happens here, right? Because that's really what we want to know. I mean, if you own a business, if I sell this much more, well, how much profit will I get out of that? That's pretty much what you want to know. And this degree of operating leverage is going to actually help us jump quickly to that answer. Okay, that's what we're going to take a look at here. Here's the formula. I told you it's not hard. Degree of operating leverage is equal to contribution margin divided by net operating income. Now, you know on your table you have 3 columns, right? You have totals, per units, and percentages. The only column that you have a total for net operating income is the total column. So these are total dollar values here. That's all they can be, right? So contribution margin divided by net operating income. Because remember what contribution margin means. This goes back to that first conversation about contribution margin. It represents what you have left over to cover fixed costs and earn some profit, right? Once you break even, everything is after that is all profit, right? Because break even means you just are able to cover your fixed costs. Everything after that, on top of that, is additional operating income or operating profit. Remember, I use those 2 words interchangeably. So textbook term here, operating leverage is a measure of how sensitive, not you're feeling sensitive. Don't care about those. No, I'm just kidding. I do care about your feelings. Sensitive in terms of how does it affect your bottom line. Okay? How sensitive net operating income is to percentage changes in sales. Percentage changes in sales. or how a percentage change in sales volume will affect profits. All right, so that'll make more sense once we look at an example. All right, so you guys, I know you remember this now, right? This should look familiar. If it doesn't look familiar, I'm going to be worried because it's like week 3 on this example here of RBC, right? So RBC, Racing Bicycles, sells 500 bikes at $500 a bike. It's $250,000 in sales. $300 per bike is what it costs to make. $300 a bike times 500 bikes is $150,000. Contribution margin is $100,000. Fixed cost $80,000. Net operating income $20,000, right? Okay. Now, if we just plug numbers, if we just look at our formula, contribution margin, which is this $100,000, divided by $20,000 gives us this number 5. You see no labels on this 5 or anything like that, so let's talk about what that 5 means. And I've been kind of going through this anytime we have a problem so that you guys understand how numbers can be expressed. So 5 is 5, same thing as 5.0, right? Or same thing as 500%, okay? In our expression for this particular problem, I'm going to stick with just the 5, but here's what I want you to make sure you write after it, 5 times. So it's the number of times, and I'm going to write this down. This is the number of times net operating income will increase for every 1% increase in sales. So the formula is not hard. It's the interpretation that we want to make sure we understand, that you understand what 5 times means. So if sales increase 1 percentage point, net operating income is going to go up 5 times or 5%. Okay? That's all it means. If sales go up 1%, net operating income is going to go up 5%. Because I said 5 times that 1% is 5%. Right? That's all it means. So in this example, if RBC is going to increase its sales by 10%, then we're going to take the 5 times 10%, and we're going to say, okay, my net operating income is going to go up by 50%. So this is what RBC is saying is going to happen. So here's what this means in terms of our financial statement. So look up here. It says sales are going to go up by 10%. So increase of 10%, right? What this degree of operating leverage is telling me is that this number, if this number alone goes up by 10%, I can sort of ignore all that for now. This number should go up by 50%. You think, wow, that sounds like a lot. Well, that's exactly what's going to happen. Now, you know we can prove that, right? We can prove it by going back and actually filling in these columns with our total numbers to see if it really does go up by 50%. So that's what this degree of operating leverage is suggesting. That if RBC just increases its sales by 10%, okay, they're going to have an additional 50% of income. That's what this means right here. That's exactly what we're going to see explained here in the next slide. Okay, everybody pay attention so you know where all these numbers come from. If you have your PowerPoints, which you should, I still see people without PowerPoints. It's not a good thing. There's a lot of PowerPoints in this chapter. I give them to you in Canvas. It's your responsibility to print them out. You're only hurting yourself here by not having these in front of you so that you can jot down some additional notes even. All right, so original column, right? Tired of that probably. But 500 bikes sold at $500 a bike. That's where we get the 250. You don't see the per unit column here, but hopefully it's up here. 500 bikes at $300 variable cost, $150,000. 500 bikes at a contribution margin of $200 per unit. Okay, that's where that comes from. Now, if you just sell 10% more, you just got done doing this with that homework assignment, right? 500 bikes times 1.10, right? 500 itself plus another 10% gives me 550 bikes. So if I increase my sales by 10% or 50 bikes, now I'm selling 550 bikes. Take 550 bikes times those per unit values. 550 bikes times $500 a bike. None of my prices are changing. It's $275,000, right? This is also a 10% increase too, right? Because 10% of 250,000 is 25,000, right? Add that on, that gives you 275. Okay, 550 bikes times $300 a bike is 165,000. 550 times 200, right? 110. Fixed costs don't change in this scenario. And now look what my new net operating income is, 30,000. So you say, yes, my net operating income went up. But is there a formula that I can use to determine if that increases 50%? Yes, there is. This formula is not an accounting formula. It is a, like, I need to know this for my life formula. And you learn this in economics. To calculate the percentage change in anything, or the percentage change, increase or decrease. And I always use year as just my sort of my formula, my variable. It can be month, it can be, in this case, this is net operating income 1, net operating income 2. It doesn't really matter what it is. The point is that these are the values that you're trying to determine the percentage increase in. So my year 2 is my second net income there, 30,000 minus the 20,000, right? That's year 1. So I went from making 20,000 in year 1 or month 1 or whatever it was to making 30,000 in year 2. I want to know how much my income increased by. We call this number the change, right? This is just the change. That's an increase of 10,000. We divide by the original number. Is it a 50% increase from year 1 to year 2? Yes, it is. Why is this helpful to you in life? Well, when you get the letter that says your tuition went up from this much last year to this much this year, and they don't tell you the percentage, and you're like, well, I want to know what that is in terms of a percentage, now you know how to figure it out. If your electric bill goes up, or your water bill goes up, or anything goes up, and you're not sure what percentage, because the percentages sort of tell us a little bit more than just the numbers themselves. You know, are we keeping up with inflation? A lot of people like to compare those numbers to what current inflation is, right? Which is pretty low right now, but still, you kind of want to know if your prices are going up, or your prices are increasing higher than inflation. This is one way to do that comparison. All right, so we just proved it, right? If we increase sales just by 10%, 50 units, or $25,000, that's going to increase operating income by 50%. Got it? All right. Got your coffee clutch notes? Table? Take it out. Come on. Told you I was going to come back to it. Here's your little coffee clutch table, because I'm not rewriting all that on the board. So for coffee clutch, we're going to calculate degree of operating leverage. Okay, so degree of operating leverage for coffee clutch. Contribution margin, what is it? I should have like 20 people yelling this out. Not net operating income. I hear mumbling. 1,000 what? 73. Okay. Everybody should have a calculator. Do the math. What do you got? Yeah, if you look at your choices here, you can kind of see that you have to carry 2 decimal places, right? So it is 2.21. 2.21 times. So here's what I'm most interested in, is this translation or this interpretation, right? This is the number of times by which net operating income will increase for every 1% increase in sales. That's what you need to know. Write it down. Can't understand it unless you're writing it out and you're reviewing it. That's the number of times by which net operating income will increase for every 1% increase in sales. So again, if we fill out our contribution format table, then we should be good to go as far as the numbers that we need to plug into the formula. Okay, so this is only really the first step. We use this number now to help us to predict potential increases in operating income. So if Coffee Klatch is able to increase its sales by 20%, they're able to increase sales by 20%, by how much should net operating income increase? Well, all I need to do is take that 2.21 and multiply it by what? 20%. I don't even need a calculator. I get 44.2%. So what's that's telling me is this. Look, in this example, this is going to go up 20%, right? That's what it's saying. If sales increase by 20%, my net operating income should increase by 44.2%. That's what this is suggesting, regardless of what's going on in between here. Okay, it's a nice shortcut for me. Because really, as a manager, that's what I want to know. How my bottom line is going to change. How's my bottom line going to change? Okay, now let's prove it. When I say prove it, we're going to compare the old income statement to the new income statement. So your Coffee Klatch table, take a look at your total column. Take a look at your total column. All right, and let's move on here to the next screen. Well, actually 2 screens. Okay. So you guys should have this first column right here already written down somewhere, right? 2,100 cups is what Coffee Klatch sells on average per month. 31.29 was our total sales. And we got that number by saying 2,100 cups times $1.49 a cup of coffee, right? If you look at your per unit column. 2,100 cups times 36 cents was how much it cost us to make a cup of coffee, a variable cost. That's where we got the 7.56. 31.29 minus 7.56 is 23.73, or 2,100 cups times $1.13 a cup, right? It's 23.73. Fixed cost for that problem were 1,300, so that's where we came up with net operating income of 1,073. If sales go up by 20% or 20% more cups of coffee, so 2,100 cups times 1.2, right? 2,100 cups times 1.2, because that's a 20% increase, gives me now 2,520 cups of coffee. Take the new number of cups of coffee times those per unit values that are on your table. 25.20 times $1.49 a cup of coffee means I should have total sales in coffee of $37.55. You guys following? 2,520 cups of coffee times 36 cents a cup to make, 907. Just do the subtraction here, or you can say 25.20 times $1.13, which is our per unit contribution margin, right? Subtract the same amount of fixed costs, and now we have net operating income of $15.48. Yes, we can see that it's an increase, but is it a 44.2% increase? We have to keep in mind, too, that these numbers have been rounded slightly, okay? But we do the same thing that we did for our example problem. 1,548 minus 1,073, okay? Divided by 1,073. And you get 0.4426 something, yeah. So if you round it, it rounds to 44.3%, but that's because we had to round these numbers too. So it's slightly a little higher, but yeah, 44.2%. So how did I do that again? Look, plug those numbers into this formula right here. This works with anything, not just what we're doing. So 1548, if you want to see, I can't tell you how many times I used this over my lifetime when I got a raise or something like that, which was usually expressed to me like as a lump sum. Here's your raise for the year. Like, I wanted to know what percentage that was, because if it was 2%, then I wasn't real happy. If it was like 12%, then I was real happy. You see what I mean? Like, you kind of gives you a different perspective on the number. And so I always use this to figure out what my increase was, if it didn't state specifically on the document that I would get that tells me I was getting a raise. Things like that. Or if your 401k has increased or something like that, and you want to know by how much. Most of the time when you get reports, they tell you the overall increase over a certain period of time or by quarter, things like that. But this is really useful when you want to know by how much, or if something went down, then your number would be negative. If your number goes down, then this is a negative percentage, which would indicate a decrease in the value or the balance of something. That can be as well, okay? It's a great calculation just to know. All right, guys, any questions? All right, so you're gonna do one, and then I'm gonna go over it with you here, but I'm gonna have you try this on your own. So this is page 219, and this is problem or exercise 9. Page 219, exercise 9. Everybody should be working on this. This exercise asks you to do 3 things. The first 2, pretty simple. Calculate the degree of operating leverage. So that's the formula that's on your slide. We just did it. I just erased it, but it's up here. Right? That's this formula. The second part says, all right, estimate the impact on profit using that degree of operating leverage. So that's just that quick multiplication calculation. And lastly, number 3, it says to verify. If you're going to verify, what are you going to do for me? You're going to show me the original contribution margin income statement, and then you're going to compare it to the new one side by side, just like you saw for Coffee Clutch. That's what part 3 should look like, that slide that we just saw for Coffee Clutch. So I'm going to give you a couple of minutes here to take a look at that, and then I am going to put it on the board, but everybody should be trying it at least. No point in taking notes, you're not going to use them. Use the PowerPoints, use the notes that I give you. So the first one, number 1, you're just plugging the numbers into that simple formula. It says using the degree of operating leverage. So what's that mean? Yes, using that number. What's the impact of 5% increase in sales? This you're not going to do till you go to prove it number 3. Did you take notes? Okay, you're missing something here though. I took this another step, you don't have that. Slides. You took this and multiplied that something. The increase. Number 1 and number 2 should take you like a minute, right? Plugging that into that simple formula. Number 2, you're just multiplying. Number 3 is your proof, so you do have to go through. Now for number 3, folks, you don't have, listen, you don't need this. This is actually unnecessary, okay? But in number 3, you don't have unit sales either, which you really don't need. If you are in this problem, if sales are going to go up by 5%, knowing the definition of variable cost, they should also do what? Go up by 5%. Variable cost will increase or decrease, right? direct proportion to changes in sales. So if your sales go up 5%, that means you're selling 5% more of your item or whatever it is, which means you have to make 5% more of your item, which means you're going to spend more money doing that, right? So your variable costs are those expenses associated with making your product. So if sales go up 5%, variable expenses go up 5%, then what else is going to go up 5%? Contribution margin. What's going to stay the same? Fixed expenses. So that's how you approach part 3. All right. Contribution margin in this problem, 48,000, right? Net operating income, 10,000, so 4.8 times. What does that mean? Number of times by which net operating income will increase. And actually, it's increase or decrease, really, right? So we could add that in there. Increase or decrease. Yeah. Oh, I don't know why I was writing the letter D there. I really don't know. For every 1% increase or decrease, technically, yes. In what? In sales. Yes. All right. So number 2, if sales are going to go up 5%, then my net operating income should increase how many times? Should increase 4.8 times or 24%. So in other words, what that's suggesting is that, and we're going to prove it here in a minute, my sales go up 5% in this problem, then my net operating income is going to go up 24%. So number 3 says to verify. Well, let's do that. So we have sales, variable cost, contribution margin, fixed cost, net operating income. And we have 2 total columns here because that's what we're comparing. The first is given, right? The easiest way to do this is to say, we're going to take this times 1.05, right? Which now gives us what? 84,000. If sales go up by 5%, the new sales amount will be 84,000. If sales go up, variable expenses will also go up by 5%, which is, okay? And theoretically, so will contribution margin, or I can just do the math this way. Either way, what's that come out to be? 400? Okay. We just said fixed costs don't change, right? Not in this problem. So now 12,400 is my new net operating income. And the question here is this an increase of 24%? Well, we plug it into our little formula, which is to find the percentage change, we are going to take 12,400 minus 10,000. I mean, obviously you can do that math in your head, but I'm just trying to stick with the formula here. Divided by the original value of 10,000, and yes, you'd say 2,400 divided by 10,000 certainly is 24%. The other way you could do that is you could just say 10,000 times 1.24, right, is 12,400. Yeah, I confirm that, right? So you could do it that way because you already know the percentage. You already know the percentage that you're looking for, so excellent. Any questions? Okay, so these wonderful Chapter 5 review questions, once you start taking a look at here the last few minutes that we have, you start working on these. There are 8 problems. They're fairly comprehensive. And they're combinations of calculations in each problem. So it's not like one problem. It doesn't necessarily go in order like you did in the book. So you're going to have to use your notes, use your slides, your examples, example exercise that we did together. This is a large portion of the review for your next exam. When you're working on these problems, a couple of things. Pay attention, listen. Make sure you're writing out and showing all your work. Get in the habit of doing it. Don't say, okay, well, I'll do that on the test, because then you don't. You don't think about it. Write out your calculations so that you can see them, so that I can see them. That's how you learn how to do the problems. Write out your calculations. Make sure you're labeling things correctly. If you label them correctly in the review sheet, there's a greater likelihood that you're going to label them correctly on the exam. Dollar signs where dollar signs go. In this degree of operating leverage, it was number of times, right? It wasn't a dollar sign. Don't put a dollar sign in front of that 5 or that 4.8 or whatever it was. It's not going to be right. Get in the habit of approaching these review sheets like you're doing a test, because I pull the questions right from the review sheets. So you want to master the questions on the review sheet, get to the test, and you're not going to have any trouble. You're going to have to go through your notes. I don't expect you to memorize formulas, but I do expect you to look them up in order to do these problems. You have a good 5 minutes here left. Use your time wisely. You say, well, 5 minutes, that's not enough time. If you waste 5 minutes every hour, all day long, how much total time have you wasted? Right? You got to look at it like that.